Let's finish chapter number 7, talking about somatomeres and somites. So these two terms are associated with each other since they are um, derived from the original band or bands of paraxial mesoderm on the sides of the notochord. So you can say that somatomeres are the primordium or primordia of somites, and both are coming from, or both are actually subdivisions of the paraxial mesoderm. It's been observed that the rostral part of developing embryos, the head portion or anterior portions of the neural tube or notochord to be more exact, are possessing on both sides of it regular segmentation. No, and this regular segmentation uh, later on develop into whorls of cells that will actually become somites. So these regular segmentations on the rostral side or the rostral portion of the animal are known as somatomeres. When these somatomeres become more compact or begin to compact as whorls of cells that are bounded by an outer basal lamina, okay, separating it from the rest, and we can call it somites. The somites, unlike somatomeres, are possessing a central cavity in which the central cavity contains the apical portions of the cells. The central cavity is where the apical portions of the cells are facing, and these apical surfaces of the cells comprising the somites are actually bound together by tight junctions. Then outermost, or the external surface of the somites, are actually bound by a basal lamina. In terms of the development sequence, the first pair of somites actually is derived from the eighth pair of somitomere. If you're or eighth pair of somatomeres. If you're going to take a look at page 248 of the textbook, you will be able to appreciate an avian embryo on top view. So you'll be seeing the 7 pairs of somatomeres on the rostral side or the rostral portion of the animal, and the eighth pair of somatomere will actually become the first pair of somite or first pair of somites. Then the trend will be like one pair of somites will be formed every 100 minutes. Then the maximum will be 50 pairs, no, until 50 pairs of somites can be seen. Now, these somites undergo further specialization. So their inductive signals derive or coming from the neural tube and the notochord that will allow somites to become more specialized. Okay. Inductive signals from the notochord and the neural tube will make the somites will make the somatic cells on the ventromedial wall of the somites to actually lose their epithelial properties. By the way, the cells comprising the somites are possessing epithelial properties. Now, when inductive signals are produced by the notochord and the neural tube, okay, the first portion of the somite or somites that will respond are the ventromedial portions or the ventromedial cells. These ventromedial cells comprise the sclerotome. So they will lose their epithelial characteristics, they will transform as secondary mesenchyme, and they will migrate. Or to be more exact, they will emigrate from the somite towards the ventral side of the neural tube and towards the notochord. So these sclerotomal cells